seen this static and dynamic bindings. We had started polymorphism, and we were able to do these kind of statements in which we say animal d1 is equal to new dog. So we put a dog object inside an animal object because animal is the subclass, the upper class. So now we will talk about this casting part. So we change the object type, like when it's a dog, but we put on an animal or so. So I would like to talk about this. First, for that one, instance of operator is important because, but we have seen already what it is in the previous chapter. So what was it? Just as a reminder, this is an operator that shows that if we have this shape 1 instance of circle, it means that it checks whether shape 1 instance is from a class that is either a circle or a subclass of circle. So if there's a relationship between circle or not, so it returns true or false. So, and we had also used this get class method, but in a get class method, it wasn't checking subclasses. It just checks, okay, is it a circle or not? Like even though let's say it's a rectangle, like a subclass, it would give us a different result. But instead of like circle, rectangle, triangle, all of them are circles. Shapes. I'm sorry. Then it would return true. If they are not circle objects, then it would give us false. So we had seen this in the equals function, but we also use it in the casting part. So how is that? Well, we have these upcasting and downcasting, two versions. When we say, in the previous example, in the previous slides, what we were saying is animal d1 is equal to new dog. When we were saying that, we are actually doing this upcasting one. How is this upcasting? Well, in this example, for instance, we say animal A is equal to new cat. So I'm taking a cat, it's a specific animal, and I'm putting it in a more general part, animal class. So this is upcasting part. And the downcasting is the reverse. So we say that, okay, cat C is equal to new animal. So cat is a specific object compared to animal, but I'm saying that, okay, this will be an animal. And when you do this on a computer, you will get actually compilation error. Why is that? Well, because you might think in this way. In an upcasting, I don't get any compilation error because cat is an animal. So I'm just putting an animal to an animal object. There is no problem with this. But here, when I'm trying to put animal inside a cat, well, dog can be also an animal, or mouse can be also an animal. So not all animals are cat. So that's why I cannot put it. I will get a compilation error. So when I say all cats are animals, so I can do this. But when I'm saying all animals are not cat, so this will give us an error. If we apply this to our example that we do for our e-commerce platform, if you remember. So in that one, if you remember, we had these toy, food, and water, and we had and all of them were basically extending this item class. Okay, so similar to that. Now, when I'm trying to in my main method, I will zoom in again a little bit more. I can say, okay, toy T is equal to new item. Okay, and I think I have T here. Yeah, that's the reason. Okay, I'll put toy then.
You can't assign it more than one time if you initialize it.
Yeah, I was using the same variable name. That was the reason. I was and I think for the item object, it looks like we don't have. Oh no, we have it. Okay. No, we have it. What is this error then? Oh yeah. Okay. Yeah, this is what we are doing. I'm confused. Sorry. This is downcasting. Now we are getting an error. But if I had done the same thing in the reverse order, I would not get an error. This is called upcasting. Why is this? Again, casting. So every toy is an item. So that's why it's not. There's no way that I'm putting here a maybe not an item object. I know that toy is an object. Toy is an item. But here I'm saying that okay, toy is a new item, but an item can be also based on my code. It can be food. It can be water. So it's not it might be problematic. Maybe it's not a toy actually. That's why I'm getting here an error. This is called downcasting. Then, well, you might say, okay, which means that can we really not do it at all? Like we cannot never do the downcasting at all? No, we can do it. But when we are doing that, we really need to be sure that it is really a toy object. Okay, how can I? Because there's a way to just shut the compiler up. Okay, we can say, okay, shut up. I know that it is a toy. To stop complaining about it. How can I do it? Well, I'll just say, you know what? This is a toy. Then it stops complaining about it, and it will compile. So we have this power to say that okay, you can stop. I know that it is toy, but if you really would like to say that now you are actually taking a risk. What if it is not? Okay, we stopped the compiler. It was complaining about it, but we just casted. Okay, treat it as a toy. Okay. At this version, then I really need to be sure. How can I do it? Well, instance of operator can be useful in this case. Like now going back to switch to our story to animals and cats. Like if I want to do a downcasting to say a cat C is an animal, okay, first I really need to be sure that okay, that animal is an is a cat, okay. So for that one, what I can do is let's look at this example, which takes an animal object, and then if I really need to do a downcasting, I first need to check that okay, is this A is an instance of cat? If it is true, then yeah, I can stop compiler complaining about this, and I can safely do this. Otherwise, I'm taking a risk. What if it is not? Okay, and we had done this also in one of my previous example codes. Do you remember that? In downcasting. For the temp, yes. For the equals function, actually, let's also go that. I don't. Where was that? Let me try to find it. Equals function here. No, this is your quiz. Yeah, here. If you remember that when we are writing this equals function, which takes an object, so which means that it can be anything, any Java object. And when we were doing this, we were also using this instance of method. Why? Because in that I would like to do this downcasting. It is an object, but I want to treat it as a book. So that's why I would like to do it. But in order to be sure that first I need to check, is that really a book object or not? If it is, then I will do this downcasting. Any questions so far?
Is there any distinct uses for downcasting?
Like this one, for instance, equals function that we use. So I define an equals function in which it takes any object, but I want to compare that if these items are same books or not. But the parameter can be anything. I can put here toy, water, everything in that. Okay. So and if it is not a null, then I will try to attempt to use this title. I need this title attribute actually. This is what I'm trying to do. But I need to be sure that okay, is this an book object or not? Let's try to run this actually. Let's go to here. And let me create this. Sorry, it's too much. A book object. Okay. And I think it takes some arguments, name and price. Yeah. Okay. Let's write it. name and some number. Okay. Then what I can do is now, since it's an equals function that takes anything, I can put it there toy, and then it will give me some result. Because it's an object, I can put anything there. But in my calculation, why do I need this downcasting? Well, here again, when I go to here, in order to compare that, okay, if these are two same book objects, based on my story, I need to check their title. If their title are same, then I'll consider that they are same book objects. But I can put here a toy, and a toy object doesn't have this title attribute. Or so, and also from this object, it doesn't have any attributes. Like if I try to say this dot title equals O dot title, O is my object, I will get an error because Java will say, okay, what is title? Object class doesn't have this attribute title. So first I need to tell to Java compiler that, okay, I know that you are seeing this as a Java, but in the runtime, the user put their book object, and I'm sure about it. Why? Because I use this instance of, and it gives me true. Then I can tell, okay, now treat it as a book object. This is what I'm doing. Any questions so far?
So what is the point of letting the method take any object? Why not books? Why not only books? If we want to compare just books, why you make
Yes.
take any object?
Well, if I turn this off, okay, and I have only some function that takes book object only, okay, whatever it does, then this one will be only the one that is coming from the object that is not treated, okay, and I can only put here only the book objects, any book object, but not any other object. If in my scenario, if I need to compare all different types of objects, then I need it. Like I'm trying to build a more general application, actually, a more general function that can be used in more different scenarios. Otherwise, what I should have done is, like, this is an equals method that takes book object. This is this equals method that takes toy object, that takes those all different objects. I don't want to do it. And this is the reason that, and sometimes, again, maybe I really don't know the data type. So the user says, okay, are these two objects same? One of them is a book, the other one is a toy, but maybe in the runtime we might not know it. This is why we might need those kind of general functions that can work with any object. All right, shall I proceed? This is an example that doesn't use instance of. So is the instance of really necessary? Well, it is necessary to be sure that that you can do this downcasting. But if you don't do it, well, if you don't use it, you can still do the downcasting, but just accept the risk. If there is the possibility that it cannot be, in this example, maybe it's not a cat, then you might be in a trouble. But if you are really sure that when I run this method, this animal will be always a cat object or its subclasses, then you don't need to use this instance of method.